This is the second video for August 11th and 14th. And we're talking about radians and degrees and how they are related. On the previous video, we talked about how we got these radian measurements. I'm not going to spend time on that, but that's where we ended up. Again, if you haven't been in class, the unit circle will be on my board, so you can look at that unit circle. If you have questions about that, please ask me in terms of where those degrees and radians came from. Now, next what we did is, so any radian measure on our unit circle, we can figure out the degrees pretty quickly just by looking at it and seeing how they were, if it's 5, 5, or 6, well, that's going to be 150 degrees because that's what is on our circle. But what if it's not on our circle? So we wanted to develop a formula that's going to convert degrees to radians every single time. And we were able to do that by, what I said is, hey, if we have 180 degrees, which would be here, this is going to be 180 degrees. This would be 360, well, let me write it here, 360 degrees. Then the goal is we're going to multiply that by something, and if we multiply that by something, then we'll get the radian measure, or in other words, we'll get pi, because 180 and pi are related. Similarly, if we do 360 and we multiply by something, that would give us 2 pi. And I gave students time, we talked about it, and we figured out that if we multiply this by pi over 180, then that should give us pi. And let's check it out. So if we multiply fractions, we could rewrite 180 as 180 over 1. And now we have two fractions, we can multiply them. If we have two fractions that we're multiplying, you multiply straight across. So this would be 180 pi over 180. And then these 180s would divide out and you would just be left with pi, which is what we wanted. And we could do that over here, pi over 180. Put this over 1. But 360 divided by 180 would give us 2. We're left with that pi, which is there. So these are our conversion formulas for degrees to radians, or our conversion formula from degrees to radians. Similar, we could do that for radians to degrees. Let's say I want to go from pi over 2, multiply by something. Well, pi over 2 is here. That's going to be 90 degrees. So whatever I multiply, I want to get 90 degrees. I'm going to let you try it on your own to check it, but it will be 180 over pi. I'll let you check that, see if you get that as 90. Simplify that fraction. Same thing for 3 pi over 2. If we multiply that by 180 over pi, the degree measurement for that would be 270. So these are our conversion formulas. If we wanted to convert from degrees to radians, we can do that by multiplying by pi over 180. However, if we want to convert from radians to degrees, we can do that by multiplying by 180 over pi to get those degrees. If you need to pause it, rewind, please do so. I just summarized that here. Again, if you want to pause it and write that down, great. If not, that's fine. I'm going to keep going though. So then we talked about, what about angles that are bigger than 360, bigger than 2 pi? I'm not going to do this because in a lot of classes we didn't get here, we didn't get to this point. And we're going to go over that on Tuesday and Wednesday on August 15th and 16th. So you don't need to worry about this piece here. But let's talk about on the circle, if let's say we have 450 degrees. What I let students do is, so for example, here we know all the way around the circle is 360. But I asked students, do you know, like Tony Hawk skater can do a 720, and so if he does a 720, that's like doing it again. So it's 2 times around. So I go around the circle once, and then go around the circle again. That's a 720. So it should make sense that we can get to 450. It should make sense that we can get to 690. And we can do that. So what students did is said, hey, well, one of the ways they did it is said 450 Well, I know it's going to be all the way around the circle once, and it's going to be bigger than 360, so I need to figure out how much left. And so what they did is said, hey, I can subtract 360, and if I subtract 360 from here, that gives me 90. Or in other words, if I need to go 450, then I need to go all the way around the circle once, which is the 360, but then I also have to go this additional 90. So I'd go from here to this additional 90. And so 450 would end up being here. That's 450 degrees. Similarly, if we have 690, we could do something similar. So 690, I'm going to go around the circle once. So I'm going to take away the 360 to figure out how much more to go. And that's going to give me 330. So 330 on our unit circle would be here. And so 690 and 330, they end in the same spot. Now, I'm going to visualize this for 450. 450 started here, goes all the way around the circle once, and then goes an extra 90, ends up here. If I started here and it just went 90, it would be like this. So what's happening with the 450 is that we're starting in the same place. We're starting on the positive x-axis, but we're also ending in the same place. The values are different, but we're starting and ending in the same place. So what we say is that 40 degrees and 90 degrees are what we call coterminal. Co meaning together, terminal means end, angles. And 690 and 330, because of here, those are also coterminal angles. And so we can find these coterminal angles. It's going to be really helpful for us to find those in terms of degrees. In some classes, we did talk about 7 pi. I'm just going to go, if you need to pause, rewind, please feel free to do so. I'm going to just talk about 7 pi, and then 9 pi over 4, we're going to talk about on Tuesday and Wednesday, as well as Thursday and Friday, August basically 15th through 18th. But 7 pi, so here, if this is 0, then if I go here, that's 1 pi. If I go here, that's 2 pi, which means this should be hopefully 3 pi, 4 pi, 5, 6, 7. So 7 pi would end up here, which means that its coterminal, one of its coterminal, I should say, is pi, because pi ends up here as well. That's essentially what we did on August 11th and August 14th. If you have questions, please feel free to come talk to me, ask me, reach out to me. But we will continue dealing with coterminal angles on August 15th and 16th, and pushing even more into August 17th and 18th.